Okay, so I'm going to use this video to run through a few examples of the Hess cycle calculations. The first one I'm going to go through, you are asked to calculate the enthalpy change of reaction for the following reactions. And you are given the enthalpy change of formation. So you're given this information here. So I've just written this out for myself, that I'm given the enthalpy change of formation data, and I'm asked to calculate the enthalpy change of reaction. And the first reaction in 2A is this reaction here. So essentially what I'm trying to find is the energy change when this reaction takes place. I want to know, is it exothermic, is energy being released, or is it endothermic and energy is being absorbed? And for some reason with this particular reaction, it's difficult to calculate this using an experiment, so we're going to use the Hess cycle instead. So they've given you the enthalpy change of formation data. And what that means is they give you the energy change that occurs when you form 1 mole of ammonia from its elements. And they give you the energy change that occurs when you form 1 mole of hydrogen chloride and when you form 1 mole of ammonium chloride. Okay, so at the bottom here, in order to construct my cycle, I'm going to write the names of the elements which make up these compounds. Okay, so in NH3, the elements that I have, I've got nitrogen, and I've got hydrogen. And in HCl, I've got hydrogen, which I've already written down, and I've got chlorine, so I'm going to add chlorine to my list. And if I look at the product side, I've got nitrogen, I've already written that, I've got hydrogen, I've already written that, and I've got chlorine, and I've already written that. So these three elements can be used to make the compounds that I've got on the reactant side, or these three elements can be used to make the compounds that I've got on the product side. So I can draw an arrow from my elements to the reactant side, but I can also draw an arrow from the elements to the products side. So I'm going from the elements to the reactants, or from the elements to the products. And now I've got three arrows drawn. I've got a little cycle. I'm going to label these arrows as A, B, and C. It doesn't matter where you start with A. I could start here, here, or even here. I'm just going to start here with the reactants. I'm going to call this arrow A. I'm going to call this arrow here B. And I'm going to call this arrow here C. What I'm actually trying to find is B, okay? I want to find out the energy change that occurs when this reaction takes place. I'm trying to find B. But I need to write myself an equation in terms of A, B, and C first, and then solve for B, all right? So what I can do, if I'm starting out here with the elements, okay, just say this is my starting point, and this is my finish point. There's two different ways that I can get from my start point to my end point. I can go the direct way, I can go along pathway C, or I can go the kind of more roundabout way and go along A and then along B. I can then say that A plus B equals C, okay? Because I can go along A and along B to end up at NH4Cl, or I can just go along C. So I can say A plus B equals C, okay? As I've already mentioned, it's B that you're actually interested in. So what I'm going to do is I'm going to rewrite my equation so that I have B equals C minus A. What I need to do now is use the information given to me in the question to find C, use the information given me in the question to find A, and once I've got that, I'm going to do C minus A, and that gives me B, which is what I'm trying to find. So I told you already, they've given you the delta FH values, okay? So they've given you the delta FH values for A and for C. And if I look at my table, it tells me that the energy required to calculate 1 mole of NH3 is minus 46. Over here, I'm going to calculate what A equals. And I've got minus 46. And they tell me the energy when HCl is formed is minus 93. So I do minus 46, minus 93, and I end up with minus 139. And that is my value for A. I then go over and I work out C. I've only got one molecule on the C side, and if I consult my table, I see that the value for NH4Cl is minus 314. So now I've got my value for C. It's B that I want to calculate. I know what C is, I know what A is, I just need to plug that into this equation. So B equals C, which is minus 314, minus And then A is minus 139. So hopefully from your maths, you remember that if you've got minus minus, it becomes a plus. Sorry, 139. And that gives me a final answer of minus 175. Okay, the next one, this is 2b. Again, I'm given a chemical reaction and I am asked to find the enthalpy change of this reaction. Okay, and again, for whatever reason, you can't find this by just doing the experiment. You have to find it indirectly using Hess cycle. And because I'm given the formation data, I'm going to do this in exactly the same way as before. So if I look at the elements I've got on the left-hand side, I have got nitrogen, and I have got hydrogen, and I've got chlorine, and I've also got calcium, I'm just going to write Ca, and I've got oxygen. They are all the elements I've got on the left-hand side. If I look on the right-hand side, I've got calcium, I have got chlorine, I have got nitrogen, I've got hydrogen, I've got oxygen. So obviously it's a balanced chemical reaction. The elements you've got on the left are the same as the elements you've got on the right. So I could again say, if I had all of these elements, I could use these elements to form the compounds on the reactant side, or I could use these elements to form the compounds I've got on the product side. So I can draw two arrows going this way. If I'm forming compounds from the elements, from their elements, that is called the enthalpy change of formation. Okay? Again, if I'm forming these compounds here from their elements, that is again called the enthalpy change of formation. And if you look at the table you're given the values to find out these two sides of the triangle, and then you can use that to find your third side. So again, I'm going to label this as A, B, and C. This time I'm just going to call this one A, I'm going to call this one B, and this one C, because it really doesn't matter which way you label it, okay? So again, I need to write myself an equation relating A, B, and C, okay? If I start here with all of the elements, and if I want to get over here to the product side, again, there's two ways I can do this. I can go the direct way along B, or I can go the more roundabout way, first up along C and then along A. So I can write that C plus A, so going this way and then this way, is exactly the same as if I just go along B. Okay, and I told you it's A that we're trying to find, so I'm going to rearrange this equation to have B minus C, because it's A that I'm trying to find. Okay, so once I know what B is and what C is, I'm going to be able to find A. To find out what B is, we said this is the delta H of formation. Those values are given to you in the table. So I'm going to find over here, what C is. And you have to use the large numbers that you've got in the equation. So I didn't have that in the first example. I've got it here now. So I've got 2 times the value for NH4Cl is minus 314. And then I'm adding on the value for CaOH2, which is minus 986. There's no big number in front of calcium hydroxide. So I work all that out and I get minus 1614. And that is my answer for C. Then I come over here to the other side and I'm going to work out what B equals. So B equals, I've got CaCl2, which is minus 796. I've got a big 2 in front of NH3, so it's going to be 2 times minus 46. And then at the end, I've got my water, and again, I've got 2, and the value for H2O is minus 286. So I work all of that out, and I end up with a value of minus 1460. Okay, so here you've got 2 times minus 46, so you're going to end up with a negative sign there. So it's going to be minus 796, minus 92 it works out as, and then here at the end it's going to be minus 572, and you end up with minus 460. So I've calculated C, and now I've calculated B. A equals B minus C, so I'm going to take my value for B, which I had over here, minus 1460, minus C is going to be minus 1614. That's going to give me minus times minus is plus. And if I work that out, I get plus 154. So what this is telling me is it's an endothermic reaction because I've got a positive value and heat energy is absorbed as this main reaction here takes place. All right, so we're going to look at one more. This is the reaction that you're given in the question. Again, you're trying to find the enthalpy change for this reaction here. Again, for whatever reason, you can't do it in the lab, so you're going to use the Hess cycle instead. They've given you the enthalpy change of formation data. Okay, so if I look at the reactants, I have got nitrogen, and I've got hydrogen, and I've got copper, and I've got oxygen. And on the other side here, I've got nitrogen, I've got copper, I've got hydrogen, and I've got oxygen. You don't actually need to write out the names of the elements. You could just write the word elements, okay? But if you start off with all of these elements, you could use these elements to form the compounds on the reactant side, or you could use these elements to form what you've got on the product side. And when you're going from the elements to the compound, that is called the enthalpy change of formation. And again, I'm going from the elements to the compounds, and that is called the enthalpy change of formation. I'm going to label this again, A, B, and C. I'm going to go A, B, C, but again, it doesn't matter what way you do that. I'm going to write myself an equation, okay? I can go from A along B and end up with the products, or I could just go along pathway C. So I can say A plus B equals C. Again, the way I've labeled things, it's B that I'm trying to find. So I'm going to write B equals C minus A. And I just need to find C and find A so that I can go back and find B. Okay, so I'm going to find A first, again, using the values that they've given me in the table. I've got a big 2 again in front of the NH3, so I do use that number. So I do 2 times minus 46. Plus a big 3 here in front of copper oxide. So it's going to be 3 times minus 157. I work that out and I get minus 563. And that is my answer for A, minus 563. On the other side, I'm going to be calculating C. Okay, I'll do it here. C equals, all right? And if you look at your table, you see that there is no value for nitrogen, okay? The reason is these are the changes in energy when you're forming a compound from its elements. Nitrogen is not a compound. Nitrogen is an element. It occurs naturally. It doesn't need to be formed. So the value would just be 0, and it's not included in the table. So anytime you've got an element instead of a compound, you're not going to have a value for the delta HF. Okay, nitrogen is going to be 0. Similarly, copper is also going to be 0. It's an element, it's not a compound. It's not going to have a value. So I can leave out the nitrogen, or if you want, you could write 0, and you've got 3 times 0, which is just going to be 0. And then at the end, you've got 3 times H2O. H2O is a compound, so it does have a value, and you get 3 times 286. When you work that out, you get minus 858. So there is my value for C, minus 858. Plug that back into my equation. C equals minus 858. Then I've got minus 563. The minus gives me a plus, and I end up with a value of minus 295. And that tells me this is an exothermic reaction and heat energy is released. What you'll notice, if you look back over the three reactions that we've done, it was always been this side minus this side. In other words, the products minus the reactants. And you can learn that as a rule if you want to, that if you're given the delta HF and if you're asked for the delta HR, that it's going to be products minus reactants every single time. However, the other reaction that we're going to look at is the opposite, and it might be tricky in an exam to remember which way around it goes. These cycles aren't particularly difficult to draw, and if you understand it and you understand which way the arrows are going and you can write your own equations, you're never going to make that mistake, okay? If you're relying on just learning that it's products minus reactants, because the other one's going to be the other way around, if you mix that up in the exam, well, then you're just going to get it wrong, okay? So those three are all effectively the same. We're now going to look at the other example, which is when you're given the enthalpy change of combustion data and you're asked to find the enthalpy change of formation. Okay, so having a look at 3, one of the main differences you'll notice is you're not actually given an equation, you're expected to construct your own. So you're asked to calculate the enthalpy change of formation. That is delta FH, that's what you're asked for, and you're given the enthalpy change of combustion. The first thing you're going to need to do is write yourself an equation, okay? So the first one you're asked about is C6H14. You are trying to form C6H14, therefore C6H14 is your product. Whatever they give you, that's going to go on your products side. So I'm going to write myself an equation, and I'm going to put C6H14 here on the product side. When I'm making C6H14, it has to be from the elements, okay? So if I look, I've got carbon and hydrogen. Carbon as an element, I write as C, okay? It's not diatomic. Hydrogen as an element, I write as H2 because it is diatomic. I need to go back and balance this, but when I'm balancing this, and this is really important, you can only balance using numbers on the left-hand side. Your equation has to form 1 mole of C6H14 because that's your definition for the enthalpy change of formation. Only 1 mole is formed. So I cannot put any numbers on the right-hand side when I am balancing. I can still balance it. It does still work out fine. You just can't use the right-hand side. So here I've got C6, okay? So I'm going to put a big 6 here in front of the C. I've got 14 hydrogens, so I need a big 7 in front of the H2. So there's my balanced equation. And this is what I'm asked for, okay? To find the energy change when C6H14 is formed from its elements in their standard states. All right, you're given combustion data. Okay, so combustion, another word for combustion, is just burning. So basically you're burning these things. What do you get when you burn carbon? Okay, if you're burning carbon, you are reacting it with oxygen and you typically form CO2. If you burn hydrogen, you're reacting with oxygen and you form H2O. Okay, so I can get from the reactant side to CO2 and H2O by burning them. Okay, so I'm just going to write combustion would allow me to get from the reactant side to CO2 and H2O. The exact same products are formed if you combust C6H14. Okay, anytime you combust hydrogen and carbon, if you combust hydrogen, you're reacting with water. Sorry, with oxygen, you're going to form water. When you're combusting anything with carbon in it, carbon reacts with oxygen and it forms CO2. So I can now construct this triangle that looks like this, okay? And I'm going to label it as A, B, and C, just like I did before. But you'll notice the key difference is the arrows are now pointing this way instead of this way, okay? So now when I'm writing my little equations, if I start here at my reactant side, and I'm trying to get down here to CO2 and H2O, there's 2 different ways I can go. I can go the direct route, I can go along A, or I can go a slightly longer way and go along B, and then down C. So I can write A equals B plus C. It's B that we're interested in. That's what we're trying to find. So if I rearrange the equation to make B equals, I can write B equals A minus C. So I need to find A and I need to find C and then plug them into this equation. All right. So in order to find A, I'm going to use the values that they've given me in the book. Okay. They've given me the combustion data, and this is a combustion reaction. So they've told me that if I were to combust carbon, if I were to react with oxygen, then I'm going to have minus 394 kilojoules per mole. Because I've got a large 6 here, it's going to be 6 times minus 394. Okay. And then I've got H2, so it's 7 times H2 is minus 286. I work that out and I end up with minus 4366. On the other side, I look at my table and I see that if I combust C, there's no calculation to do. I'm getting minus 4163. So there's no calculation to do. That's my final answer. So now I have B equals A, which is minus 4366, minus C, which is going to be minus times minus, which makes it a plus 4163. Sorry, I shouldn't have written 2 3s there. I work that out and I get minus 203 as my answer. Okay, just to know here, because I usually get asked this, why in the previous questions, when we had elements, the value was 0, and then down here, I've got elements in my equation, and the values are not 0, okay? Back up here, the values were 0, because in the table, the values they were giving you was the enthalpy change of formation, the energy released when something was formed. Nitrogen and copper are elements, they can't be formed, so their delta HF was 0. But in this cycle, you don't have delta HF, you've got delta HC, the energy released when these things are burned. And you can burn carbon and it will release energy. So it doesn't matter if it's an element or it's a compound, they can be burned, they can release energy. It's only when you're given the formation data that all of the elements are going to equal 0. And the last one here, 3b, you're asked for the enthalpy change of formation for C2H5OH. Okay, again, you're forming C2H5OH, so that's going to sit on your product side, and you need to write an equation where you're making this from the elements. So it's got the elements carbon, hydrogen, and oxygen, and you need to write those elements in their standard state. So by standard states, I just mean as they appear on the periodic table. So C, O, and H, but if they're diatomic, you do need to include that. So carbon is not diatomic, so I leave it as C. Oxygen is diatomic, so I write it as O2. Hydrogen is diatomic, so I write it as H2. That's my equation. I need to balance it. And again, when I'm balancing it, I can't put any numbers on the right-hand side because I can only be forming 1 mole. All the numbers must go on the left. I've got 2 carbons on the right, so a big 2 there, balances that. In terms of your hydrogens, make sure you're counting this properly. I've got 5 there and 1 there. Just alcohols are commonly written with this hydrogen on the end, but you still just count them as 5 plus 1 is 6. So I need a big 3 in front of the H2 to give me 6 on each side. I've got 1 oxygen here and I've got 2 here. So again, I can't put any number on the right-hand side, so I need to put a half in front of the O2 to give me 1 on the left and 1 on the right. So there's my balanced equation. Okay. If I were to take these elements, carbon and hydrogen and oxygen, if I were to combust them, I would get CO2 and H2O. Similarly, if I were to combust ethanol, C2H5OH, I would also get CO2 and H2O. I'm then going to write myself a little triangle, A, B, and C. Okay, this is what I'm trying to find, the delta FH. Okay, and this is the information that I'm given in the table, the combustion data, the energy release when these things are combusted. I'm going to write myself a little equation. Okay, so if I start here, I can get from the elements down here to the combustion products by moving along pathway A, or I could go along B and then along C. So I can write A equals B plus C. It's B that I'm interested in, so I'm going to write B equals A minus C, and then work out A and work out C and plug them in there. Okay, so I'm going to go to the table to find out the values to calculate A. So again, I'm using the big numbers. Carbon, the value for my table is minus 394. Okay, then I've got O2. You'll see O2 is not in your table. Okay, the reason, if you're combusting something, you're reacting it with oxygen. You can't just react oxygen with itself. So there is no value of combustion for oxygen. Okay, so there's nothing for oxygen. But then for hydrogen, you can react hydrogen with oxygen. And when you do, you release 286. So if I plug all those numbers in and I work it out, I end up with minus 1646. And that is my value for A. Lost my little highlighter. And then if I go over here and do C, there's no number in the front. So I take this value straight from the table, minus 1367. So C equals minus 1367. I plug these in out here. A is minus 1646. C, it's going to be minus, which makes it a plus 1367. You work that out and you get minus 279. Okay, so if you look at the last 2 reactions that we've just done, again, there is a pattern. When you're given delta CH, when you're given the combustion data and you're asked for the formation data, it always works out as reactants. Okay, so what was on the left-hand side minus the products. So the opposite to the other questions that we did. I mean, you can risk just learning that off by heart, but again, it's very easy to confuse the two. Being able to actually draw the cycle and work it out from scratch is a better option in the exam, you're less likely to make mistakes. And these questions, I know they seem a lot of work, they're typically only worth a mark in the exam. Well, they can be worth more, it depends on what way they ask them. What we're going to do in the intervention is we'll look at a few of the exam questions and some of the questions that they ask in a different way. But just make sure that you are completely comfortable with answering these ones so that we can move on and do some of the slightly harder stuff in the intervention.